We're going to be working through the third example. When you were born, your grandmother decides to open an registered education savings plan, an RESP. Many of you guys may have an RESP. They're an incredible investment vehicle, they're called. So your grandmother decides to open up an RESP for you with an initial deposit of $500. Every year on your birthday, she deposits $300 into an RESP as a present. How much with your RESP, or how much will your RESP be worth one day after your 18th birthday? Your interest rate is compounded. So first thing I'm going to do actually is I'm just going to pull up my calculator and try to remember at the bottom, my payment is at the beginning. If you notice, there's no word beginning here. Really, that's reading too much into the question, so I'm just going to change it back to the payments at the end. So let's get back to the question again and pick it apart. So as I'm reading this, an initial deposit of $500. And then on my birthday, she deposits $300. One way of looking at it is that the present value is minus $500 because it's $500 going away from you. The payment would be negative $300 because, again, that's money going away. Now I'm going to pick apart this. My interest is 4, and here's a very special thing. It's compounded daily. So here I am just going to say compounded per year is equal to 365. So I'm missing some items here. How much will this be worth on my 18th birthday? Really, we're talking about what is the future value. So I'll calculate that. I'm going to try to pick apart how many payments per year. Now, this is our initial deposit, so we don't worry about that. But then she deposits $300 into an RESP every year on my birthday. So payments would be what? So remember that N is payments per year times years. So payments per year is 1. The years that I have, well, if I go from 0 to 18, that is going to be 18 because there's 18 regular payments, one on your first birthday, second birthday, so on all the way up to 18. So my future value, I'm just going to plug this in my calculator now. So take this out. And let's figure this out. I enter all the relevant information into my calculator, try to ensure that it's correct. Often we will make a mistake. So it's important to sort of rely on our gut instinct. So at the end, I will have $8,778. And that is actually the correct answer here. So at the end, I'm going to have $8,778.15. So how much will it be worth one day after your 18th birthday? It's going to be worth this much. Now, how much interest will be made? Now, I'm going to pull up that interesting interest function on your calculator. We have to see how many n's are going to be, and what we see is n is 18. So as I pull up my calculator, now hopefully I'm able to do this correctly. I'm going to quit this. Now that information is stored in my calculator, remember, so that if I go apps, finance again, and I'm going to go all the way down to this. This really means the summation of all the interest payments, the sum or the addition of all the interest payments added together. So I'm going to select this, and I'm just going to put 1 from 1 month to sorry, from the first year, since our payments were years, to the 18th year. And what I get is $2,878.15. Now, you could also figure that out another way if you decide to simply calculate how much money has been put in together, this plus all of these, and then subtract it from your original total. And you should end up with the same amount. Let's take a look at a fourth example now. Amy dreams of retiring at age 55. She had planned to start saving for retirement at age 50, but her financial advisor does not agree. He recommends that Amy should start to save sooner. So scenario A. Amy invests $1,000 on her 25th birthday and contributes $200 every month on an account that earns 8% compounded monthly. What will be the value of the investment on her 55th birthday? Show your work. What is Amy's rate of return? Now, I think it's quite important. This is a lot of information going on. Let's take it back to basics. And I'm just going to look up the TI-84 menu because I know that I'm going to have to use this app, the TMV Solver app. So I'm just going to pick out all the important information that it gives me. So please write down all of these variables, fill them in if you can, and I'll press on pause and I'll have them filled in. Let's see if they match. So there we have it. I have entered all of these values that I see fit. But before I get on to this, I'm just going to say rate of return. Now, that was defined a while back. My rate of return can be found as my total interest divided by my principal, and it's expressed as a percent. So we'll get down to that a little bit later. So I guess what I should probably find, though, is when I take a look at rate of return, I need to calculate the total interest. So in order to calculate the total interest, what I'm going to use is I'm going to use the PMV solver, because do you remember this function, the summation of interest? That'll give me the total interest. So I actually need to solve this previously, find this, find the summation of all interest, and we can work from there, and we can discuss what principal means. So let's just get started, enter all of this, let's calculate our future value. Looking at the question, so the number of payments So here we are. Now, what I've recognized is I've made a mistake. Let's see if we can spot out where I've made this mistake. And this is very difficult to get this right 100% of the time. So Amy invests $1,000 on her 25th birthday. So that's $1,000 away from her. $200 every month. So every month she puts away $200. So every month. Oh, that must mean that the payments per year is not 1, but rather 12. Now, into account that earns 8%, so that's good. Compounded monthly, so compounded monthly. That's good. I think I got this all. Now, oh, I forgot N. N is payments per year times the amount of years. So really, I suppose I got this wrong right here, because it's 25th birthday to 55th is 30 years, but if we're making a payment every month, what we should have is 30 times 12. So let me pull up my calculator. Let me try this again. There we have it. It's all ready to go. I'm going to select payments a year 12, and my number of payments is 12 times 30. And as soon as I enter that, it'll calculate. And I'm hoping I will get the correct answer. And in fact, there it is. There is my future value. Now my future value is going to be $309,007.62. But the question has nothing to do with future value. Well, that's sort of a nice nest egg that we have saved up. However, what is the summation of total interest? So I'm going to go back to the TI. I'm going to quit this. I'm going to go into the apps menu, the finance, the time value of money. Go down. Select this, how many payments I have. Now 1 through, this is the important thing to remember, it's 360. And the total interest that I get is $236,007.62. That is the amount of interest that I have total. And so if I'm after, what is Amy's rate of return? The rate of return simply is the total amount of interest divided by my principal, so my rate of return. So how much have I contributed totally? So my principal, well, how much did I contribute? I contributed $1,000 initially, and then $200 every month for 30 years. So that's 200. So I'm just going to put this in brackets. Times $200 times $12 times 30, and my principal that I have contributed is going to be $73,000. So my rate of return, I'm finally ready to calculate my rate of return. My rate of return is $236,007.62 divided by $73,000. Simply pull up my calculator. Look at that. It's sitting right there, right? There's my last entry. So there's no sense in using that, or there's no sense in deleting that. So I'm just going to take this amount. I'm going to divide it by $73,000. Pardon me, that's one too many zeros. Hit enter, and I get a rate of return of 3.23 ... Now, what does this mean? Well, I have to express it as a percent. So really, I have to multiply this number by 100 to express it as a percent. Now this seems very impressive, but it is the nature of investing. If you invest a lot of money for a long time, you will get rates of return of $323.298%. In other words, every dollar that you invested, on average, it has earned you $3.23 interest. That is impressive. All right, I'll let you try this next one on your own here for B. We'll go through this much quicker. So I am going to, Amy invest $1,000 on her 50th birthday. Oh no, Amy, that's a bad decision. Anyway, she's going to start saving retirement when it's 5 years away. How much will she have to contribute every month to match the final of the investment? So assume that the interest rate and the compounding periods are the same. So I'm going to fill this out. I'm going to press pause, and I'm going to work my way through this. Now, remember what we did last time. To calculate interest, what we needed to do is we needed to use the time value of money calculator, and we calculated the interest here, and if we use that, we can also calculate present value, and maybe, just maybe, we can get what we want. I'll let you try to figure it out. Let's see where we end up. So let's look at this question here. If Amy invests $1,000 on her birthday, how much will she have to contribute each month? So it's really asking, what is the monthly payment to match the final value investment A? Our final value, our future value investment A, is this crazy number here. Let's assume that we get the same interest rate and compounding periods. So now we just have to keep in mind, she goes from her 50th birthday to her 55th birthday. This is 5 years. So again, we're making monthly payments. We're compounded monthly. Our future value is this. Initially, she puts $1,000 of investment and an interest rate of 8%. Now, the number of payments always is your payments per year times your years. So when we enter this amount, let's just quickly plug that into this magical calculator and see what we get. So we're calculating the monthly payment she would need. So this is what it looks like if somebody starts to retire or starts planning for retirement late. So actually all my information is pretty much the same. I have to change my number of payments to 60. My payment I'm trying to figure out, so I'm just going to put a bunch of 9s there to remind me. My future value is the same. Payments per year is the same. Compounding period is the same. So really, how much will she have to, what will her final or monthly payments have to be? Survey says, wow, she will have to make payments of $4,085.23 per month in the last 5 years in order to save the same amount. So, really super fundamentally important idea in real life. How do you get rich? Well, let's be honest here, $309,000 is a lot of money, but I would not describe that as somebody saved only that much for their retirement as being rich. You could contribute $25 or $200 every month for 30 years, and that's how much you have. Or if you're going to wait, you have to save over $4,000 a month. There's not too many people I know who are capable of saving this much each month. So I recommend buckle down for the long haul and start saving for retirement. Start saving now. It's even that much better.